Okay, so the problem is that there's an old farmer named Tom who has grown a record-breaking carrot that has a mass of 22 kilograms. Therefore, Tom wants to take his carrot to the Guinness Book of Records fair. In order to do that, Tom needs to lift his carrot 1.5 meters above the ground to put it in his car or truck. He decides to use a lever that has a 0.8 efficiency. If Tom can push a maximum force of 250 newtons, what distance does he need to push the lever? Okay, so knowing that this problem contains a lever with input and output forces and distances, we will use the work in equals work out equation, which expands to the input force times the input distance equals the output force times the output distance. And we are solving for the input distance because Tom inputs a force and a distance into the lever, which then outputs a force and distance that lifts the carrot. Given this, we can plug in the variables in this problem. So 250 newtons, which is the input force, times the input distance, the variable we are solving for, equals 220 newtons, the output distance or the weight of the carrot, times 1.5 meters, which is the output distance that the carrot is lifted. Just a quick reminder, one finds the weight of an object by multiplying the mass of an object in kilograms with the g value or the gravitational attraction, which is 10 meters per second square on Earth, and that gets us the weight with units in newtons. So in this case, the carrot is 22 kilograms, and we multiply it by 10 meters per second square, which equals 220 newtons. Okay, but before we solve for the input distance, we cannot disregard that the lever has a 0.8 or 80% efficiency. The equation for efficiency is efficiency equals work out divided by the work in, which also can be written as efficiency times work in equals work out. Therefore, in the equation we have written so far, we need to multiply the work in by 0.8. And now we can solve for the required input distance. So we can divide both sides by 0.8. We get 250 newtons times the input distance equals 412.5 newtons times meters. Divide both sides by 250 newtons so we can isolate the input distance. And we get the input distance to equal 1.65 meters. Thank you.